Good afternoon, everyone. Today we're going to do a problem where my friend Mitchell starts rowing from a dock, and he rows first 5 kilometers along the direction described by the bearing north 34 degrees east, and then further by 8 kilometers in the direction described by the bearing of north 65 degrees west. Okay. Now, from where he's going to end up, we're going to find his total distance traveled and his direction as a bearing from his home dock, his starting point, to his finishing point, okay? So first off, let's draw a diagram. So if he starts, let's say here at his home dock, where he takes off, he's first gonna travel 5 kilometers north, 34 degrees east. Now, north is obviously straight upwards, east is over here, and west is over there. And so north 34 degrees east means we're going north and then veering off by 34 degrees towards the east. So something like that. An estimate is good enough. And so then we're going to travel 5 kilometers in this direction. Yeah, we'll leave it like that. And then I'll label this side length 5 kilometers. Okay. Now, from that point, he then goes 8 kilometers north, 65 degrees west. So from this point again, north would be straight up ahead. So he's gonna go north and then 65 degrees west. So that 34 degrees east was north and then 34 degrees towards the east. Now we're gonna go north 65 degrees towards the west. And so his second travel point is gonna be something like 65 degrees, something like that. Right, that would be 90 degrees, maybe a bit more, something like this. And then he's gonna travel something like that. That's 5 kilometers. Now he's traveling 8 kilometers. And so, let's make it look somewhat accurate. And then, obviously, you can imagine his journey ends like so, okay? So, we're looking to find his total distance traveled, which means all 3 sides together. We already have 2 sides. This is 5 kilometers. This leg is 8 kilometers. And so we need to find this last distance. Let's call this D. And we need to find his endpoint as a bearing from his home dock, okay? So, meaning how do we go from here to there in one foul swoop, okay? So, first things first, let's label what we can inside our diagram. So, whenever we have north lines, like so, we know that these lines are parallel, right? And that's often really important to further our diagram. Now, since this line here, the north line is parallel to this line, we know we can apply some of the geometry, let's call them geometry theorems, for lack of a better word, like the Z theorem, right, which I'm sure you are already familiar with. You might notice a Z like so. And the Z theorem tells us that opposite interior angles are equal, right? And so this 34-degree angle is also this angle in here, okay? And now you can see that all of this makes up one side of a straight line, right? And we know that one side of a straight line adds up to 180 degrees, right? What's the word I'm looking for? Encompasses 180 degrees, sums up to 180 degrees. In any case, we have 65 degrees in this part, we have 34 degrees in this part, and so now that allows us to find this interior angle in there. And we're going to find that angle by, we're going to do, I'll make an arrow, 180, right? Because it's one side of a line, so it's 180 in total. Take away this one and that one. Minus 65 degrees, minus 34 degrees, which leaves us with 65 and 34 out of 99. And so that's 81 degrees in here, right? Now, what else can we do? With this information, we can for sure find the distance, right? Because we have its opposite angle inside of a triangle, and we have the other two side lengths. And so with our cosine law, we can right away solve for D, right? I'll get rid of this west. So, using the cosine law, we can find D, because D squared is equal to 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of the opposite angle from it, i.e. cosine of 81 degrees. You can plug this into a calculator, so D is the square root of all that. 64 plus 25 minus 80 times cos of 81 degrees, which means that our third length D is the square root of 89 minus 80 times cos of 81. Please be mindful with your negatives, make sure your bed mass is done appropriately in this step, right? You want to multiply these two before you start subtracting them from the first two terms. And if you do it properly, you should get a third length of 8.75. 8.75 kilometers. So that's our third distance here, 8.75 kilometers. And so it's asking for the total distance that Mitchell traveled. And so we can now add up all three side lengths. So total distance is 8.75 plus 5 plus 8, which is 21.75 kilometers total travel. Okay, so that's part one. Part one complete. Now, how are we going to find this as a bearing from our home plate over to his endpoint? Because it's from his home dock over to his endpoint, right? So we know we're going to go north. We're not going south. So we're for sure heading north. And then we're veering off towards the west, right? Again, because the west is over here, east is to the right, west is to the left, right? So it's going to be north and some amount of degrees towards the west direction. So how can we find this angle in here? Well, if you look at our big triangle, if we could find this entire interior angle, if we could find this entire angle, we could simply subtract 34 from it, and then we get this little guy. And that would serve as the bearing. We could write it north blank many degrees west, right? And so now we can use our sine law, right? We're looking for an interior angle. We already have one, and we have all the other side lengths, and so the sine law is going to work very well for this situation. So we're looking for, let's call this angle, well, let's call it theta, since we haven't used theta yet today. So we'll have sine of theta over the opposite side length. Opposite to this angle is 8. And so, using our sine law, we can write sine of theta over 8 is equal to, we don't know this angle yet. We do know this angle, and opposite from this angle is the side length, 8.75. And so we'll have sine of 81 degrees over 8.75. And now we're going to rely on our algebra, right? Make sure that all this works out, yeah. So then we have sine of theta multiplied by 8 on both sides. Sine of theta is equal to this stuff, 8 times sine of 81 over 8.75. And now we want theta, and so we're going to take the inverse sine. And so our angle theta is the inverse sine of all of that. 8 times sine of 81 degrees all over 8.75, which means that our angle theta, using a calculator, is going to be the inverse sine of 8 times sine of 81, all divided by 8.75. Make sure your brackets are put in properly. And we get an angle of 64.6 degrees. And again, I'll remind you that theta we labeled as that entire angle. What we really want to express our direction as a bearing is we want this little sliver here, right? We don't have a name for it, so let's label it something. Let's label it alpha. Sometimes we use the symbol alpha for missing angles. So in that case, we can say that alpha is going to be the entire angle, which was 64.6 degrees, minus this part, which we know is already 34 degrees. And so alpha is the difference between those two, which is, that is 30.6 degrees, okay? And again, that's north, 30.6 degrees towards the west. That would take us from his home dock over to his endpoint. This is where he ends his rowing journey, at least as far as we know in this example. And so we're gonna write that right here, a bit of space, Mitchell rowed for 21.75 kilometers along the direction north, so that would be north and then 30.6 degrees west. If he were to have made this journey all at once and gone directly from his home dock to his endpoint, right, is what we're kind of trying to get at. So I hope you're starting to see, when it's time to use the cosine law, when it's time to use the sine law, kind of how to use your geometry to put these diagrams together, find missing angles and whatnot. Thank you for watching. Let me know if you have any comments, suggestions, and have a good day.